This part, so the first one is here. We call this place script, right? So this is the R script. Okay. So what is this? This is just like a writing part, right? Whatever we do or whatever command we write will be written here. Is that okay? We can use this as calculator. So for example, we all know what the answer will be, right? Okay, so how do I get the answer? I can place the cursor anywhere on the line, or I can highlight it, whichever one is okay for you. Okay, so if I place it anywhere, I use this. So this is run, or run the current line or selection. Because I have increased my font so that you see all those, otherwise you see run. So on your own, you may see run over there. Okay. So if I do this, what do you see? I run it. What happened? Okay. So down there, you see this prompt sign, which is the greater than sign. It repeats whatever was here that we ran. And then the next thing is what? The result. Is that okay? So this place is what we call the console. So the console is where it's just like the engine of ours. That's where all our computations will be done. Is that okay? If we have to get a result, that's where we will get it. Is that okay? So here the script is for what? It's for writing, so to speak. It's just like a writing part for us. That's where we do all our computations. Once we do that, it appears on the console. So for example, today is Saturday, right? People stake lotto, right? Okay, so now I'm not saying you should go and stake, because if that is the case, I will be a millionaire by now. Okay, so we can actually sample. They have this lotto that out of 90, they select 5, right? The winning number is 5. So don't worry, we will come back to this. I just want to show you that I want to select 5 numbers out of 90. So 1 in R, if we do, let's say 1 to 10, then it means we are listing numbers 1, 2, 3 up to 10. So the colon is just to move in steps of 1. It means that I can also move from, let's say, 20 to 4. What do you think? It means we'll count backwards to 4. Yeah, so what I have done here is that I want 1 to 90. Right? That's it. And I want to select 5 numbers. Okay, so let's all run this and see what happens. Okay, so the numbers in my random sampling that I got, it's 40, single 9, 60, 26, and single 1. I said, don't go and stake it. You do so at your own. Okay, so that's it. But what are we trying to see? You see, what we did was over here and then there. Okay, so please run your own and tell me whether you got the same numbers as mine. You got what?
11, 47.
Okay, so you got 11, 47, 52. Yes, next person. 20.
15, 49.
Okay, so it means that if you go and stake, if you want to stake, you stake around. Okay, but essentially this is what we call random sampling, right? Okay. Random sampling. Is everybody okay? Yes. All right, but don't forget, whatever we did over here, we got our answers where? In the console. Okay. We'll come back to this. Random sampling, we'll do this with replacement, without replacement. But essentially, what happens is that here, each of us we are all getting different results. I can let us sample from the same place and we'll get the same result. Most of us. Okay. That's why when they are doing raffles, sometimes if it's a radio station, then they say no relative of a presenter and so forth should take part, right? Okay. because if I'm the one generating this, I can actually set the seed so that I can tell somebody elsewhere to also get the same numbers. Did you get what I'm saying? Yeah. So, yeah. Yes.
We need to set a seed.
Oh, so it's just like you know, computers do not actually generate random numbers. They are called pseudo-random numbers. Okay, so it's just like, let's say we give it a starting point. So we expect that all of us will get the same thing. We can try it. You just say, in R, we call it set.seed. You set.seed like this. Okay, but you need to give it a number. That number, all of us should use the same number. It can be any number between 1 to infinity, right? Just that you can't put infinity. So let's assume that we put in 1, 2, 3. So 123. It means all of us should use the same number, right? Okay, then we do it. Then I call this again. So this one is generating, and this is for comments, right? It means that anything after it is what? It's assumed not to be run, even though we run it. Okay, it won't execute to give us anything. So generating same random numbers. Okay, so please do it. Remember the first one, we all got different results, right? Now, if we run this and we sample, please do it and let's see how many of you got this. Usually, I think it depends on the processor. Some of us will get different results, but you realize that they will be the same with other people. Okay. Did you get the same thing? You got the same, all the numbers. Okay, any other person? Just set the seed. You must run it before you run the set of seed. Then you generate your numbers again. What did you get? The same number. Okay. Anyone else? Same. Okay. You are using Mac. Did you get the same? Okay. Who else? You got a different one. The same. Okay. You got different. Yeah. Which laptop? No. It's always happens. Which one? Dell Windows. Okay. HP. It's so usually sometimes the processor. So. The teacher's laptop. Do we have some here? TM1. You got to say.
I'm not trying it.
Okay. So, but this is, you see, this is what really random sampling is one of the main reasons we do statistics, right? Okay, because if we have a population and we can get access to all of them, there's no need for statistics because we are just calculating whatever we got. But now, if I call Joy FM now that I have done a poll, I have interviewed 1,000 people, and MPP or NDC is winning. As soon as it is MPP, then NDC says, you, how did you get your sample? Who did you, and so forth. Okay, they will start pointing holes all over. If it is also in favor of NDC, MPP will start, this man, who did he vote for the last time? And so forth. Yeah, so what we are going to do is that if we are interviewing, let's say, 1,000 people who we are using to represent over 10 million people who are going to vote, then we must choose these people randomly such that we expect that their views will represent who? All the over 10 million people. Is that okay? And that means we have to use randomness or introduce randomness. We cannot go to just Medina and go and interview people in Medina, and then we expect that their views will be the same as those in Bunkrubu Yoyo or Cape Coast. okay, or whole, and so forth. Okay. So we will be doing this random sampling, and let's say if you are going to households to interview them, you do not just get up, you want to go to Asinfosu to now go and interview, let's say, 10 households. You now want to take a car to Asinfosu, then when you go and count all of them, all the households, and then select one. No, we won't finish in a day, right? Okay. So even counting of the houses, you will need maybe several people to help you to do it. So how do you go about it? Well, we can go to statistical service. They did population and housing survey, right? Or census last 4 years, right? So we can get a number of the households in Asinfosu. Then we can number them maybe 1 to 100,000. We want to interview 10 people, so we can then use 1 to 100,000. Then the size will be what? 10. We sample them. Once we sample, and maybe the first one is 2, I can do it now. Let's say what I mean is this. So 1 to 100,000. The size is what? 10. Okay. Now, so I do this. So it means that if I go to statistical service and I get the households, these are the households I'm going to interview. So the household that is number 62,708. The next one is what? 6,746. The next one is 16,128, and so forth. So it means that when I'm going to Asinfosu, so I'm just going to this household straight away. When I finish, I'm going to what? This one. Then I go to this one. I go to that one, and then lastly this one. So in this case, you are not going there. You do your sampling in the office before you move to Asinfosu. You cannot go there and be roaming around numbering them all over. Is everybody okay with this? Yes. Yeah, so that's what I said, that even though we are learning how to do, we will be doing our statistics as we move on. So now we know what is called random sampling, isn't it? Yeah, and how do you do it? We can use sample in now to do so. Later on, we'll come to this. We'll do sampling with replacement, without replacement, and so forth. All right, okay. Any question? Okay, so, yes. Yes.
But I want to do road. Even if you increase it, you get the same answer.
No, we'll get different values.
Yes.
Yes.
But it wouldn't change.
No, we'll get the same, but the numbers may be different. Yeah. So we can, let's say, add, let's say, 7 or 8. So if I do this and I run the selection of the household, I got it. If you also put this one, then you run, you get the same thing. Yeah, that's what we mean. Okay. Any question? Okay. So basically, we are saying that here we do all our stuff, we run it, we get the results and all, the console. Is everybody okay? Good. Next, I move on. Over here, you see environment, right? Now, the R says what? Environment is what? Empty. So how do we get things stored in our? The environment is the storage area. Okay, that's where we will store our data. That's where we will also store our functions. Or what we, in general, we say what? Objects. Good. So what do? We can do so by doing what we call assignment statement. Okay. So we can store information in R or objects in R using the assignment statement. And what is the assignment statement? It is like this, or it could be like that. But however, we'll use the left-hand side one all the time. Okay. So, I can now generate my Lotto numbers again. So my Lotto numbers, remember we did it over here. And Now I am naming it. Okay, so what this means is that assign what is on the right hand side to the left hand side, and we give it the name. So it's the lotto is now an object containing what? Lotto numbers. Is everybody okay? Okay. So now let's run this. We run it. What do you see? What are the changes you see in now? What else? What additional? There's what? So on the environment, you now see what? Lotto. So what we did is called an assignment statement. We are assigning what is generated here to what? To the left hand side. Okay. Did you get the same?
Yes, sir.
You got 28. Good. Okay. So this means that when you do the set.seed, it runs only once. Okay, then thereafter it doesn't take effect again. Okay. So that's the Lotto numbers. Okay. Now, if we want to assign and display at the same time, assign and display, then what we need to do is that whatever we did, we will now put it in what? Quotation marks again. So we assign and then we display. That's putting it in parentheses. Okay, so this one, what it means is that I'm going to, let me do it Lotto 1. It is going to assign the generation of the sample to Lotto 1 and display it on the console at the same time. Is everybody okay with it? Okay, so let's do it. Okay, what happens? So Lotto 1 is stored. It is also displayed on what? The console. Okay. Now the next thing is, how do we display stored objects? So when you want to display stored object, you just call the name. Is that okay? So I can call Lotto and run it. Okay, the numbers in Lotto is what? Displayed. Or I can just highlight it over here and run it. It's also displayed. Okay, so either you run the name or you highlight the name and all and run it. Any one of them will help you display the objects. Okay, so that's it with the environment. And I can only display what is in the environment. Okay, so
It's not determines the displacement.
which one?
The heading is assign and display.
There,
Unless
yes.
You have to put that one to determine whether to.
So this one, the first one, generates it and assign a Lotto. The parenthesis means display this one. Is that okay? Yeah. Okay. Now, so that's it. Okay, so let me call raffle. What do you see? Error. What? Raffle. Have we declared any raffle here? No. So it means that if you don't have anything in your environment, you cannot what? Display it. Is everybody okay with this? Good. So whenever you see this error, you should know what error you have committed and how to what? Rectify it. Okay. So it means that if I want raffle, it means I may have to come back and what? And do some sampling. Okay. So maybe here I do 1 to 100. I select 10 of them. Okay. So this one, once I do it, now I can display what? Raffle. So usually when this happens, it means, let's say you have written it on your script, but you have not run it. And then you are calling the name raffle, it won't appear. So you must always run it, let it appear on what? The environment before you can what? you can retrieve it. Okay. Any question again? Okay. If in the absence of question, we move on to the next one, which is history. So history will keep track of all the commands we have executed. Yes. I'm moving fast. Where are you? You are still with Raffle. When we have already taken our okay. But you can increase the font size. Let's try that. Let's go to view. And zoom. You can do it again. You are following. Okay. So, have you been able to do the raffle? Okay. So it's the same. Let's see, narrowing. You will not find functions because your sample, your destiny is wrong. Some. So that's one thing with R as well. So if I forgot to, so R is case sensitive, right? So for example, this raffle, if I now call in my environment there's raffle, but it's with capital R. If you use small r, it will not. It will tell you that object raffle was not found. Is everybody okay with it? So please make sure that you always have the correct. So please click on history. When you click on history, you will see that all the commands we have executed today, you will find it as what? History. So history stores all the commands we execute. Now, when you click on history, if you still want to redo it, you can do so. You can either send it to the source or you can bring it to what? The console. So let's assume that you mistakenly delete your command. Okay? You mistakenly deleted it. So let's assume, click on here and then you get a new one. So we are assuming that all this that we did today, we no longer have it because we mistakenly deleted it. Either yourself or maybe your daughter. Yes. Who will be using your laptop to play. So, okay, so you can just highlight this. Okay, I can highlight all of them. Okay, once I do it, I can send it to the source or to the console. The source will be where? The script. But the console, it will bring everything out to the console. So I can do this. And you see, I have generated what we did, we have done today. Is that okay? So that's the importance of the history. Okay. We could have also sent it to what? The console and run it. But the console, anything you write on the console, as soon as you close out, it's gone. Okay, but if it is at the script, you will still what? Have it anytime you open it. Okay, so that's it with history. Next, connections and tutorial. You can have tutorials in our studio there. Okay, if you have time, just go there, click on it. It will install the tutorial package, learn how, and you can learn some of these things we are doing over there. So that's it with tutorial. I hope I'm not moving fast. Oh, is there? You click over here. And then the Learn Now package is required to run our tutorials for us. So if you click it, you install Learn Now, and then you can do so. Is everybody okay? Okay. Yes. The history. Oh, you need to hold down CTRL. Okay. So then, but if it is just one, then you can just highlight it. Any question? Can we move on? You have to tell me so that we can move on. Shall we? Okay, then you click on Files. So the files will just give you all the files you have in the folder R is currently residing. Files. So click over there. You are not going to see unit. You won't see that. Because you don't have that in your file. Right? In your folder, I should say. So you click on Files and let's see what you have to click on Files. Okay, so this yours is in my document. We will create a folder for this and have you click on? No, the one here. That is fine. Click over there. Let's see. So, okay, good. Okay, so that's it. But this is, usually it will be in my documents, right? But that's not where you're going to do. I want you to create a folder now on your either desktop or your OneDrive or Dropbox. Create a folder. Name it as 607. Create a folder either on desktop or whatever you want to name it as 607. As 607. 607. Okay. Are you done?
Yes.
Hurry up. Hurry up. Create a folder. So just on your desktop, just go to desktop and then right click it. And then new folder. And then name it the course code after 607. Why the teachers one doesn't have new folder?
We have.
Don't worry, the next one, when my hammer comes, will give you a MacBook. Oh, yeah, the same digitization. Okay, so just create a folder. What we are going to do is to let our reside in that folder so that all our history and data will be stored in there. Anytime we want to open we'll open up from that folder. So if you have done so, please go over here, session. Go to session. So a session, when you open R like this, that's a session. So go there and then save, so save workspace, I think. Yes. Good. Okay. Save workspace. Oh no, I think it's set working directory. Go there, lesson. You go to session. No, I think set working directory. Yes. Set working directory. We will save it later on. So go to session, then set working directory. Remember that our environment, we now want to set it to a directory, right? Which is a folder. So let me also do it from here. So this is what I'm saying. You go to set working directory. Then you have to choose the directory, right? So go and choose your folder. So when you say choose working directory, you have it like this. So in my case, this is, it should have been after. Okay, so 607 weekend. Yes, then you click on it. So navigate to where you stored it. So you see, once you do that, look over here. Look on the console. A new file path will show. So see so until you're after 607. Is everybody okay? So that's so you see now files, there's nothing there. Because there's no, we just created it. There's no, at first you would have seen some other document. Now there's nothing. Okay. Now, if you look over here too, it says untitled, right? So it means your script, you have not saved it. You can also save it. So you can click. I'm sure most of you don't know what this is. Those that were born after 2000. The millennium ones, they don't know like this is over here. Okay, so, but that's a diskette. That's what we use to store data. I think the maximum was 256 kilobytes. Okay, so click on it, or you can go to File and then Save As. So that's save. But because you have not saved it, if you click on it, it will open a window, right? Yes. So what window? What's the folder? Yes. What folder? Good. Why is it so? Because we set our working directory. So whatever we need to save, it will give us the first option of what? Saving it in that folder. Is everybody okay with it? Okay, so please let's save it. Maybe the same, like after 607. And then you click on it. Please observe whatever is happening in terms of colors and what have you. What happened? What do you notice now? Yes. Everybody is murmuring. I'm not hearing what you are saying. If you notice anything, just tell us. It's no more red. It's black. Black what? Good. So it means this name is now changed to what? After 607. Now, so if you have saved your command, it appears as black. If there are any unsaved commands, it will appear as red. And the key thing is that once you set your working directory, whenever you want to save anything, it goes into that folder page. Okay, let's move on. So that's it with how to. Now, when we want to close R, it will now tell us, do we want to save? Then we say save. It will save in that folder. So you must take note of this. And when you are at the workplace and you are working, okay, let's say different clients, you open folders for them. When you are working with this client, you set your working directory to that client's folder. You have to be particular on this. Other than that, you save somebody's information and give it to the next person. And that would be disaster. Okay, so let's move on. Okay, so it means that, yes, we save this. Please go on.
And so in that case, if you want to work with a particular folder, maybe you say
Yes.
you set the directory to a certain folder for a certain client.
Yes.
And you want to work from that folder.
Yes.
And do you have to do you have some codes that you need to
You can open from that folder.
You can open
When we
from that
finish, I will be stored in that folder. So whenever you want to do that, you open from that folder and it will reside in that folder.
Yes.
Yeah. Okay. So this is what you had. Now, as soon as I start typing again, it will change to red again. Look. Which means there is a new thing I have not stored, even though I just press enter. Okay, so that's it. Okay. Now, let's move on. And remember that we are not seeing anything again. At first, I had unit something and so forth. Okay, so that's it. Next is plot. So plot is empty. So plot is where all our images or will be stored, right? So plotting area. Oh. Okay. So I'll give an example. Plot. So I want to plot the numbers 1 to 8. Oh. 1 to 8. I also want to see what are the plotting characters in R. So I do 1 to 8. And also I want to see the colors. We will come back to all this. So now just notice that you just write this. So plot 1 to 8, plotting character 1 to 8, color 1 to 8. Okay. So this is it. You do your own and plot it, let's see. Okay, can we move on? Let me see who else. Okay. Okay, so please notice what is happening. So I issue this command, plot. And when I run it within the console, you see that the command is executed. By here, you realize that for the plot, we are not getting our result on the console, right? It rather appears at all. The plot. So that's a plotting area. Now, if you look at this, the space over here is almost the same as the plot that I have. Isn't it? This one, if we copy it and we paste it in Word, we cannot write it because it's an image. Okay? So, this is one of the good things about R is that you have absolute control over your plotting area. It's not like Excel or SPSS that when I plot something, I cannot go there and be changing this. Here, you have absolute control. So what I'm going to do, I will reduce this size I'll reduce that size because, of course, if it's a report, I don't need to do any title unless a presentation. Okay. If I'm going to, let's say, do some PowerPoint presentation, and I want my audience to know that this is a plot of colors enough, then I can put that one over here, and I don't need to do anything. Because once I display it, the graph speaks by itself. Yes, is that okay? But if it is in your report, for example, your project work, or you are writing a report to your boss or whatever, then there's no need to have a title here and also figure 1 point something ahead. Is that okay? Yeah, so please take note when you are doing your project, you don't have to be given a title here and then you name it, figure something. So please collapse this file too, so that it is only, you shouldn't be seeing environment. So click over there so that the other one. Okay, so that you see the graph. Nice. So good. You do your own. Click on this. So when you are plotting, you must always okay. So when you do that, you see, I'm going to reduce this. As I said, we'll come back to plot, but this is just by the way to let you know that how R is. Okay. And this is just so I can rerun this. When I do this, I'm just closing the margins. So you see now my graph actually fits into all the plotting area. Okay. We will do all this again when we start with plotting. And this is just the basic plots we are doing, right? When we get to plotting, of course we can't do all of them, but there's even packages that can be used for doing plotting. Okay, ggplot2 and so forth, which will give us what elegant graphics that we need. So this is by definition. So what I have done here is simply to reduce the size over here. If you remember, if I go back here, look at this graph. These two graphs, which one is better? This or that one? It's the same graph, but this one gives you more, like your graph is seen more because it fits into what? The plotting area. Okay. When you copy this and you paste in Word, what you can write around the graph because the area is filled adequately. Any question? This is just one of. We will take a look at graphs. We'll do bar chart, and we'll do all of them. Box plot, and then we use real data as well to see what. Yeah. It's all. It's great. Yes. This is just the beginning. Okay. Any question? So what I want to communicate is simply this, that when you issue a plot command here, it executes on what? The console. The results is displayed at where? The plot session. Okay, good. Any question or I move on? The next is packages. Remember we were talking about packages, right? Yes. We said that package is what? A collection of data set, functions, or what? Both data sets and functions. Okay, so click on packages. When you click on packages, you will see this. You see system library, right? Good. Okay. So remember that when we went to the CRAN page for packages, where is it? Okay, I think I have. Let me. So please, if you go to the CRAN page and click on packages. Are you with me? Go to the CRAN page and click on packages. When you click on packages, you see what? 1,492, right? Packages. Now let's click on table of available packages. So you see there are so many packages. Even today is 12, right? Some were GG Alive was loaded today. GB Start, GPT Start, Comprehensive Statistical Analysis, Plant Breeding. So you see this is what? If you are here, this will be botany. Botany department. Okay, so those that are this list, WACI, West African as a crop, something improvement. Over here. They deal with plant breeding experiment. So this is a package. It's for statistical analysis of what? Plant breeding experiment. So if you are in the agricultural area and you are taking part in this course, this is a package that may be of use to you. Okay. So now, but let's go to let's copy this. GPB start, right? Okay. In R, I can check, do I have this? It's no. Now, all the over 21,000 packages, we cannot install it on R because some are very big. So you cannot be installing all these 21,000 packages on your computer. It's crash. Okay, so it is only the basic ones that you need for everyday statistics, mathematics that you have when you install. Okay. Now, if you are interested in any other one that is on the CRAN page, you need to install it to make use of it. So the next thing we do is how do we install the package? Okay. So let's look at the plant breeding one. So if you go to packages, there's what? Install, right?
Yes.
Okay. So you just click on it. Is everybody here?
Yes.
Good. So the package was a GP. It's a G. I don't want GPB. GPB. So you see, as soon as I start, if you are connected to the internet, because this one it connects to what? The RCRAN. Okay, so what we were looking for is what? GPB stars. Okay, so if we want it, we just click on that, and then we click on what? Install. Okay, it takes some time, depending on the size of the package. So it's installing. Okay. So it has installed now on my case. Okay. So now if I want to look for it, I type GP, there it is. Comprehensive Statistical Analysis of what? Plant Breeding Experiment. So now this package is available for use in R. And I can click on it. Are you there? Or you are lost? Okay, so to install it, you go to install packages, install, and then start typing. Once you know the name, it will start cutting up. So yours is installed. So go down and let's see whether you see. Okay, it's there. Good. Yes. So click no. Are you connected to the internet? Okay, so okay, let's start. It says what?
Would you like to create a personal line?
Give me first. Can you do it? Okay, you restart it. Please, have you all been able to install that?
Yes, sir.
Closer.
Okay. So now, when you install it, to make it available for use, okay, please click over here for me. GP, click on it. No. Click on GPD, not the box. So on tickets. Click on this, like this. Okay, what do you see? So it moved you from packages to where? To help. Is that okay? Okay. So help. Okay. Anytime we want information on a package or a function or a data set, it is the help button that will get it. So as soon as you click over here, you move from packages to what? To help. And what do you see in there? There's a function called GLM2, right? There, or DM. It's DM2. What is it? Okay, so those doing plant breeding, they will be able to tell us what it is. We don't know, or I don't know, as of now. Okay, so now we want to know how do we use DM2. Okay, first of all, we are treating packages and help together. So please go to the help, to the script and type question mark. So use the question mark DM2. Question mark DM2. And then run it. Is it on this? actually installed. So that's okay. So when you did question my GM2, what did you? It says what? Do documentation. Then there's a problem with the house, so uninstall it. GM2. So it says for no documentation. Isn't it? Okay, good. So what this means is that if there is no documentation, it means we do not have GM2 in our working environment. Remember, we can only obtain object or data set or function that we have what? Stored in what? In the environment. Now, good. Yeah, we will come to that. Okay, so what I said you should do was this. So here, I want to do getting help. Getting help. So we are treating help and packages together. It was DM2, right? So you do this. It says, but it is giving you a hint, right, of what to do. So if you do that, what happens? You see, this one takes a bit of time. Okay, and then it searches through. So I'm going to explain what is happening. Now, it is telling us that DM2 is in what package? GPD star. Okay. So when we load the package in now, we can now have access to its content. If we have not loaded the package, its content will not be found. And that's why it was telling us that there is what? No documentation for what? DM2. So the question is, how do you load the package into R? Okay, so if you go here, you see there's this box. If you click on it, it loads the package into your environment, or we say that into your library. So taken here is the same as what? Or library GPD start. Is everybody okay? Yes. Good. Okay. So now that you have loaded it, you can now come to the help, the single question mark, and then it gives you this help on it. Okay? So this is what? Our analysis of what? Dialer method 2 data containing whatever. We don't know. Dialer method. Unless we go to plant breeding, I don't know. But this is randomized complete block design that we know in statistics. So what have we done now? That help. To get help, you use what? Question mark. Is that okay? Now, the single question mark will set through packages that are in your environment, loaded into your environment. Is everybody okay? Now, the double question mark will now set through all packages installed in R. So there's a difference between having the package installed and also loading it into a what? Environment. Is that okay? We load it into an environment when we click on it, or we run this code library of that package. So if you have loaded it, then the question mark will now go for look for help within those that you have loaded into your environment. But if you don't get any documentation on it, then it is either you have not installed it enough or you have not loaded it. It is installed, but you have not loaded it into your working environment. This is out of it. Now, when we use the double question mark, then what is going to happen is that it is going to set through all the packages you've installed in your house today. So if it doesn't find it, then it means you have not installed the package at all. That's why our itself gives you what? A hint that use what? The double question mark. So the double question mark is more, it's a deeper search, you know, it searches through every package in our. But a single one will now search through the environment, whether it's the package is loaded in it. Okay. So what we talked about also, Lucia, that you cannot be calling a function that you have not loaded or defined in your environment. That's the take home. Okay. Now we get back to packages. Now, once we load this, we can have access to what? All the functions within the package. Is that okay? All right, good. Okay, so now let's look at, I'll get back to this. Let's look at other. So let's look for question mark on this. Then I'll ask you what you think will be. You tell me which package is in. So there's a data set called anorexia, and I use question mark for it. This is what it is telling me. What can you say about this? Which package? Is anorexia a package? It is. I said it's a data that I'm looking for. I use single question mark. There's no documentation. So it means the package that contains anorexia result is, what is it? It is either not loaded or installed. So what are we going to do? We are going to try the suggestion R is given, right? Okay, so let's see. So in examinations, I will give you data. Then I'll tell you that the data is in this package. If you don't know how to load the package or how to search for the data, it means you can't move on. So you'll be there and the 3 hours will pass. Then you say another, then I say 1 hour, then the other hour will pass. Okay, so now let's see. We use the double question mark. What happens? Okay. So what does this mean? Yes. So it means that the anorexia data is in what? It's in the mass package. So for me to have access to anorexia, what do I do? What do I have to do now? We have to load what? Mass. Once it is shown here, then it means it is actually installed, just that we have not loaded it into our working environment. So how do we load package mass into our working environment? You have no result for the what? The double one. You do not have anything. That is strange. You have to check this version. Which version of R are you using? So you go to package. Okay, so let's look for mass and take it. So take mass and then search for it again and let's see. So look for package mass. You've done it. Pardon me. You take it so that you load it into the environment. Okay, so you go to packages, you look for mass. This one, then you take it. So now that I've taken it, I can look for anorexia. It gives me this. Do you have it now? You couldn't find mass. Now that's also a system like just download it again and then install it. No, I want to install it. Yeah, download this one. So please Please, have you all seen the anorexia?
Yes.
Okay, good. So now we can retrieve it. Once you can get help on it, it means you can retrieve it. So type the anorexia or run the anorexia. When we say run, it means you can just just highlight it like this. You see, without the question mark. Is that okay? Or you can just write it on its own and run it. So let's run it and see. So that's the data. That's the anorexia data. So if you look at it, it says the anorexia data is what? Data on what? Weight change. So description. The anorexia data has 72 rows and what? 3 columns. It's weight change data for young female anorexia patients. Those are people with eating disorder. Or, yes, so they are not eating and not gaining weight. So, what are the, so when you go here, you see the treat is what? Factor of what? 3 levels. That is control, cognitive behavioral treatment, and family treatment. Okay. So what is happening? Well, the first person is in the control group, which means you are not giving anything, right? Yes. You are just being used. So maybe this class, they divide us into 3. Those that will be in the control group, we can give you something to let you believe that something is happening to you when actually there is nothing. Okay. So the first person, before the intervention, the person was 80.7. After the intervention, what was it? 80.2. So this one, instead of you to gain weight, the person is still losing weight. 89, 80, same. 91, 86. So this one is gaining. Even though maybe this one he was just eating instead of. So which means even though it's controlled, the person is still gaining weight. This one is decreasing, 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 increasing, another person, decreasing, increasing, 10, let's see. Then we can move on to go to what? Those with cognitive behavioral treatment. The first person increase in weight, the next person there's a gradual increase, a slight decrease, also a decrease, almost like the Hassan. Okay, so which means the cognitive behavioral treatment is really working for people. Very. Okay, this one to increasing. Look at this one. Also, this one, oh no. This one a bit. This one too had almost 10 kg. Increase, and so forth. So, this data, we can actually be checking later on whether the two treatments, they are actually significant. In other words, they lead to what? An increase in weight. Is that okay? Yeah. Okay. So that's a hypothesis test. So this, we can also check before and after treatment. Okay. So we check whether those before the interventions and then after the interventions, if there is what? An increase in their weight. We can also check whether the control is different from the CBT and also is different from all the family treatment and so forth. So that's the sort of hypothesis testing we will be dealing with later on. Okay, and this is 3 groups, right? So if you heard of ANOVA, we can use ANOVA to test whether there are differences between what the various treatment. Okay. Any question? So now we know packages, how to use a package, how to load it, and how to install it if you don't have it. Okay. Now one question, one more question. What if, so let's go back to the packages, right? The available packages. Please look for this package. Zilling. Yes. Do you find it? No, but it's a package. So I can search for it here. So when you have a package and you can't find it in the app, you can search for it like this. You just type it in Google. So what is it saying? It says that package Zilling was removed from CRAN repository. Formerly available versions can be obtained from here. So it was archived or not more than 2 years ago. Now what happens is that if you write a package, you need to be upgrading it. Just like our phones, our apps need to be upgraded. If it is not upgraded at a point, if it is Apple, you can't use it anymore. As for Samsung, you can still use it. What's the Android, right? Okay, so, or even sometimes you can't use it, right? So it's the same with packages. It's just like an app. It needs to be upgraded. So if you are not upgrading it, they will take it out from the CRAN repository. Okay? But sometimes you will need it, right? But this one, for example, if the person who maintains it dies and nobody is interested, they will take it to the archive. Okay? Which means you can still have access to it, just that you cannot install it straight away from R. So let's go to R and start typing. We want to install Zilling. So let's type. You see, nothing is showing up. At first, when we wanted GP, it's or GPD, was it B? You see, by the time you start typing, it starts appearing. This tells you that Zilling is not in the CRAN repository. Is everybody okay with it? Yes. This one I always ask in the exam. So, what we are doing. It's not in the R repository. Yeah. That's why we are unable to install it straight away in R. So, but I said you can go to Google, type, or any other search engine, right? Type the name of the package. So it tells us that this one was removed from the CRAN repository. It is also telling us where it is what? Archive, isn't it? And once we click over there, so if you go here, you see the statistics on this. So the last one the package was created in 2004. That's why I said maybe the one maintaining it have died. That was 20 years ago. In 10 days' time, that will be 20 years. Now, and then, you see, it was being maintained, 2005. You see, the thing is that, look at 2005, how many times it was upgraded? Almost 10 times, right? Or 8. Almost 10 times within a year. So it's not, and nobody is actually paying you for this. Okay, so people do it just for the passion. Sometimes it's the work you do. So yeah, if you are teaching, you want people to use your work, and cite you, right? So you see, he or she did it for a long time. See, and then 2020, he didn't. Maybe, as I said, the person is no more. So you see, if you want to install it, you click on the last one. So once you click it, you see that it is downloading, right? Yeah. So it will download into your and it's not quite big. It's just about 736 kilobytes. Now, what is the essence of this package? Well, it is used in binary rare events. Okay, so I'll tell you an example that one of my M4 students did. So in Ghana, the immigration service, you see, people also come here to work, right? So when you come and you're a foreigner, you need to obtain a resident work permit. Okay, so they say that usually once you apply and you provide all the reasonable documents, you are granted. But once a while, some will not be granted. Okay, now that means it will be also be good to be able to get a model that will predict whether this person will be granted the work permit or not. So that was the thesis. But you see, if we have, let's say, 2,000 or 10,000 applications, only maybe 10 were not granted. So it means that 9,990 were granted. So if you compare those that were not granted with those that were granted, that's it's an imbalanced data, right? Yeah, this is 10, this is what, 9,990. So we call that rare in some, once a while. Okay, occasionally, such a thing happens. So later on, we'll be talking about logistic regression. You realize that logistic regression is not able to fit that data well. Because under logistic regression, we assume that there's approximately equal number of rejections as also to those that were not rejected. Okay, so that's the binary rate, because the outcome is either you are granted or not by 2. Okay, so her thesis was now to build a model to predict whether you will be granted or not based on certain factors like your age, like how long you've been working, where you come from, and so forth. Okay, so, but it meant that if she was not getting this package, she now has to sit and be programming all these things herself. And it's not an easy thing, okay, to do such programming. So that's why it is important that you know how to retrieve packages that are what? Archived. Because you never know when you will need such packages, even though the person is not maintaining it. Maybe the person has gone on pension, there's no incentive for the person now to do it again. But you need it, so you must find a way to install it and be able to use it. Okay, so have you downloaded it now? Yes. Good. Okay, so now if you want to install it, this is what you do. You come to install packages. You see, first we were doing it from where? The CRAN repository. But it is no more there. So what do? We can come here, and then it is what? Package archive file. That's what we downloaded. The one we downloaded was tar.gz. Right? So you click on that one, and then it opens up the folder. Is that okay? So now you go and look for where your folder, your file is. Where is it? Download. So you click on downloads, and then there it is. So you see it's what? .tar.gz. So you double click on it. Okay, and then you come and then you can click on what? Install. And I'm sure you will get, you install it, you get problems with it. And it is so that I can explain further. Were you able to install it? It says what? It says what? Error. What is it?
Dependencies, AER.
Good. Dependencies what?
AER, Amelia, Coda.
Good. Okay, so look over here. You see, if you check what we were doing previously, CRAN. Let me go back. You see this? Look over here.
Yes.
What do you see over there? Good. So, as I said, programming is not an easy thing. So when you are doing it and somebody has done some of the things you need, you borrow them and you need. So that is what we call what? Dependencies. So the Zilliq that you want to install, it depends on all the packages that are listed over there. Is that okay? So what it means is that if you want to install it, all the dependencies must be installed before the Zilliq. So how do you install the dependencies? If you come here, packages, you can separate them, separate multiple with what? Space or what? Comma. So it means that you must copy all those packages. But remember that they come with those quotation marks. You can't use them over there. You have to remove them. So you can copy to Word and then you replace all the quotation marks with what? With an empty space. Is everybody okay? Yes. Go copy all the packages you need. It is telling you that it means AER, Coda, and what have you. You saw that you can have you may type for or if you can copy and send it to you. Copy all the packages you need from AER and code them. Copy all of them. You can even do it now, so do another straight. No, click over here. Yes. No, not here. Click, yes, that's good. And paste the, and then now these ones, you must separate and replace it with, now, space. Space, yes. No. This, the apostrophe or so set, copy it. Yes. Control F. This one, only the control F. You have to select it before. And then control and then replace nothing. It's not there. Or you bring it, so put it there. Oh, no. They won't, because they won't get it from the so you install that one. Yes. No, it should be fine. At first, the one is bad, I think now they have. So just, you don't need to even, some of them they work. So just copy them and paste this in this. Yes, copy and paste. They work. That's what people are saying. So go to install. Have you copied all this? So AER to B gap. Yeah. AER. Okay, wait. Yes. Good. So select it out to B gap. Good. Copy. And then you go to install. No, not package from class. Good. And then paste it. And then install. So it works. Delete. Wait, well, were you able to install everything?
Yes.
Please download and install the Google version. Oh, okay, it's because of the outage. So please. You must install a dependency. You download a dependency. Then now you can install the same way we went through. They do get that. The same way. Is it exhibit? Okay, so go here and check. You can start typing. Yes, that's all. Have you installed it? Yes, when you finish, you might go through what you did that you did not install. The package, and then you go to the yes. So what you do? Have you installed this one has 0. If I'm on 0, okay, do it. Yes. So this one is not part. Not available. Yes, vegan is part. Vegan. Where everything is. So now you have it. Yeah. Yeah. It's all down. Okay, so I think you have. Can I move on so that when this one, when we move, you can do it? So that we move on. Yeah, you can check on this later on to make sure that it's able to with some of the vegan. So you should check all of them yeah, so I think you will know it. That's the way you if the package is archived, this is what you're going to do in order to install it. Don't worry if you are unable to install it now. You can do it later on so that we can move on. So you yes. You copy this one, but you need to remove those things from there. Otherwise, in some cases, it doesn't work. So, what you need to do, you can copy them here. You open, then you replace all the quotation marks with the blank. Yes. So that it will be left with only the comments. When you put it there, it should work. Yeah. Okay, so I think you should be, if you are unable to install it, don't worry. When you go home, try. If it doesn't work, we'll come back to it so that I can move on. What's the time? We have. So, I think now we know how to install a package. There can be hiccups here and there, sometimes problems here and there, but take your time, you should be able to do it. Okay, so that's it with the R studio environment. Is everybody okay? Yes. Good, okay. Now I need to move on to talk about data sets or data structures. So, since we are doing statistics, we will be dealing with data. So it is important that we know how data sets are stored in R. So we have what we call data structures in R. So there are 4 of them, 4 major ones. We have vector. So a vector is a one-dimensional array like this. Then 2, we have a matrix. So matrix is of this form. It is rectangular, so which means it will have rows and what? Columns. And then we have 3 data frames. That's also rectangular. I'll tell you the difference soon. And then 4, we have list. A list is just a one-dimensional array like a vector. I'm going to talk about also data types. Data types. So we have the structure and the types. The types are, we have numeric, we have character. So the numeric, we can have double, integer, and so forth, but they are all numeric, right? Character. Then we have missing values. We have factor. We have dates. Of course, when you have date, we have time. What else? Numeric, character, missing values, factor, dates. Yes, and then logical. I'm going to talk about each of them. Okay. Now, so the structure will contain some data types, right? So when we say a vector, I can have, for example, age, right? If I call the vector age, each of you will give me a value, right? I cannot ask of your age and then you say Ashanti Ray. Okay, or female, right? Yeah. So age is numeric, right? But it's a one-dimensional array. Right. Now, if I collect your age and weight, I am now getting 2 variables, and each of us here, if we are 20, we will get 2 variables, which means we have 2 columns and what? 20 rows. Because each of us will get our age and what? Our weight. Is that okay? But the data in that rectangular form that we have are all what? Numeric. Because age is numeric, weight is also what? Numeric. In statistics, we would have said they are all what? Quantitative variables or quantitative data. Is that okay? As soon as I start adding religion, then I have some numeric, some what? Non-numeric. Because your religion, you are going to say Christian, Muslim, traditional religion, and so forth. Is that okay? Groups. I add your sex, male, female, at least in Ghana. Okay. So, what is happening is that here, I can only have either numbers or characters. Right? I cannot ask of age, and I have 20 here, and here male, and so forth. Right? Okay. Now, when I come to this one, the matrix only contains one data type. So, if it is numeric, I expect all the variables to be numeric. So, I have age, weight, height, salary, number of children, how many years you've been in the university, and so forth. As soon as I start adding, let's say, character, like maybe sex, then I move to data frames. So the data frames are also rectangular, just that it can contain different data types. Is that okay? So if I have this, if I have age, weight and the level, let's say at this university, then this one, I can store this data with what? With a data frame. Is everybody okay with it? I cannot use matrix because I'm going to get this one to be numbers, so maybe this one 28, 80, this one is 31, 95, but their level may be level 100. This one is level 400. The next one is level 600. Is that okay? 85, then maybe 35, something like that. Okay. So you see, these ones, even though they are numbers, they are not actually numeric. I cannot be adding level 100 and 400, then I get level 500. What is it? Do you get it? These are just groupings. Is that okay? So this is numeric, but this one is all some characterization. So in the form of what? Like a character. Okay. So this contains only one data types, either it is numeric or it is a factor. I'll talk about factor later on. If you check the anorexia data, we have factor, right? I will talk about it. So factor is actually either nominal or the ordinal scale. Okay. Maybe for the sake of those who did not do statistics, I can talk about data, right? Now, when we have data, or we can say variable, because the variable will give us a data. Age is a variable. Now, as you start giving me your ages, I now get data, which is numeric, right? So that's why I've written it. Now, this, we can characterize them as either quantitative, or what? Qualitative. Or what we call what? Categorical. Categorical, yeah. Okay. Now, if it is quantitative, I can also divide them into discrete and what? Continuous. I'm going to explain each of them. So here, if I take gender, gender is what? Quantitative. If I take weight, it is what? Quantitative. If I take age, it's quantitative. Now here, if it is quantitative, we can describe it as either discrete or continuous. Over here, they are the whole numbers, right? So anything that we require of you, and you cannot be given like 2.5 or 3.1, that's discrete. So for example, I ask you, how many children do you have? It is either you have 0 or 1 or 2 or 3 and so forth. You cannot be calling 1.8. Even if you are pregnant, you cannot be saying 1.4. Is that okay? So that is discrete. The discrete are the whole numbers. But if I bring any measuring instrument, your weight, you stand on it, we measure your weight, maybe 80.5. That's the sort of continuous. Is everybody okay with it?
Yeah.
So the salary you get at the end of the month, will it be qualitative or quantitative? Quantitative. Okay. Is it discrete or continuous? Continuous. Because we can get some points, right? Pesos, right? Good. Okay. Now, in statistics, we have what we call level of measurement. Have you been doing this?
Yes, sir.
Then I'm just going. Okay. So you've done this. What are they? Nominal, ordinal. Good. Okay. So now, once we move over here, we can either be on the what? The interval or what? Ratio scale. Over here we can be what? Nominal or what? Ordinal. Okay. Now, our factor will be more or less that one. Right?
Yeah.
So when we have a data and it is only as a result of groupings and there's no order, we will just use factor for them. But we can have ordered factors. So if you look at the anorexia data, the CBT control, they are just groupings. So that is what, under the nominal scale. But if we were to collect data on diabetes level, okay, or the stages of cancer, okay, it will be in order. That order means maybe if you are the higher part, you are almost going. They can give you maybe 3 marks. Okay, and then you can get your wish before you go. But sometimes, maybe due to miracle, you will not go. Okay, so that's it. Yeah, so that's it, what we will be doing. Now, so the data frames will contain different data types. Then, here, these ones, list is just like vector, right?
Yeah.
But here, we can have a data frame here. Right? It can contain a data frame here. Over here, it can be a vector. Over here, it can also be a list. So the list is the most complex data structure we can have. It can contain any of these data structures we talked about. Is that okay? Yes. So that's it. That's it with data in R. So if you have data and you realize that, okay, it's rectangular, that you can have different data types, you use the data frames. And most data sets in R are represented as data frames. Some few of them you will see either matrix and so forth. Now, so the data types, I've talked about numeric. Remember, the data types will be what the structures contain. Is that okay? That's it. Missing values. Sometimes you go around to collect data. You ask, what is your salary? That question, most people will not answer. Okay? So you come back, the person has answered 35 questions. Only one question is not answered. Do you throw that data away? No. You represent what was not answered with a missing value. In R, we use NA as missing value, capital letter. So when you see NA, it means that is what? A missing value. So that's also a data type. Right. Then we have, I've talked about factor, right? Date, we all know date. When we have the time series data, you'll be doing time series. Time series data, we list it just once. We just have to provide the end, the beginning and the end point. I will get all the other ones. If it is uneven, then we can use what? We can include what? The time or the date factor. And then logical. Logicals are the true or false. Okay, so you can ask a question in which the respondents have to either, let's say, answer as true or what? False. Okay, and we will also be checking whether a condition is satisfied or not. In that case, it will either be true or false. So R also recognizes true and false. It recognizes it with capital letters. So it is either like this. When you write this in R, it understands what it is, or this. So this is also, if you write T and if you write F, it also takes it as true or false. Which means if you are naming your object, you shouldn't be using T or F to name it. Otherwise, there will be a conflict with the R objects. Okay. So now let's see how this. Oh no, I need to clean this part. Do you have another class?
Yes.
Oh. Don't worry. Why you'll be free. Which means you have to make sure that you pass all your courses so that we don't see you again. When we see you, you are coming to do MPhil. God will help us. And we will help ourselves too. Okay. All right. So now, let's see, what time do we have?
We have 5 minutes.
Oh, 5 minutes.
Yes, sir.
Oh. Okay, so let me just demonstrate to you some of the data sets. Okay, so data structures. So data structures. So vector if I want to create a vector, we do it like this. I can use what we call the C. C is actually a function in R, just letter C, which means you cannot be using C to what? This small letter C. So it says it's called a combine values into what? Vector or list. Remember what I did over there? A list and vector, they are all almost the same. The only difference is that the list, each object in the list can be any data structure or any data type. Okay. So we use C. So for example, if I call 5 people to give me their ages, maybe 21, 35. The next person is 24. The next person is 25. The next person maybe 21. Am I done? 5. Okay. So when I run this, I go to environment. Age is what? Numeric, right? Num is numeric. Is that okay? All right. I can give another, let's say, religion. Let me use sex so that we finish early. Sex, okay. So here, I can do maybe male. The next person is what? Female. I can do male again, and then female. Okay. Now I run this. Argument 4 is empty. Oh, yeah. So 1, 2, 3. There. So when you come here, you check sex. What does it say? Character is what? CHR. Is everybody okay? So the character data type, we put them together, they become what? A vector. We have numeric, we put them together, they become what? A vector. Is that okay? All right. So that's it. You can even name them, right? So if I can name the elements or name the objects in the vector. So for example, the first person is called Amma, right? So names of, let's say age or sex is the same. Names. Okay, so that will also be a vector. So let's say Abba. Hey, no, male cannot be Abba. Ali. I want only 3 letter names. Okay, the next one is female, so Abba. Male, Ali, Abu. Next, male, Ata. And then female, Abba and Amma. All of them are. So now you see age has turned into what? Named what? Numeric. If I call age, you see Ali, Abu's age, and so forth. Okay. So that's how vectors are represented in R, right? Okay. Let me show you some matrices in R. So there's data on US, right? States.x77. There it is. Okay. Now this one, it says what? Data sets related to 50 states of the United States of America. Okay, now there are so many of them, state X77. So you have the area. In this case, look at it. State. The state is a character vector. No, not this one. Okay, so this is the state X77. Look, it's a matrix. You see, it is telling us this is what? A matrix. 50 rows and 8 columns, giving the following statistics. When we say matrix, what does it mean? What is the characteristics of a matrix? It has rows and columns. Good. What else? What else?
Contain quantitative.
Only quantitative.
One data set.
It contains here
One data type.
one data type. Good. So if it is numeric, all of it will be what? Numeric. If it is character, all of it will be what? Characters. So that's it. So if you look at the state X77, it says the population estimate. So that's numeric, right? Income will be what? Quantitative or quantitative? Good. What about population per capita income?
Quantitative.
Good. Illiteracy. Percent of population. So it will be what? Quantitative. Life expectancy.
Quantitative.
Murder and quantitative. HS grad is percent high school graduates.
Quantitative.
Frost, mean days of minimum temperature below freezing level. Quantitative. Area, land area in square meter. So that's why this data is stored in what? In a matrix. Okay. You can display it, and it's quite many. So you see each state and the so this is 50 states. This is the first. So Alabama is what? 20. Alaska is 152 days. So we'll analyze some of this data later on. So for example, we want you to choose which states have, let's say, income less than the average income in the United States. You should be able to tell us what those data sets is. So this is more or less what we mean by what? A matrix. It's rectangular, which means you have rows and what? Columns. Okay. And we've seen a data frame in the form of what? The anorexia. Okay. This one, all of them were all numeric. If you check the anorexia data, what was it? It said it's what? A data frame, right? If you see what is it saying? It says what? Data frame, right? And so forth. Why is this so? Because when we displayed it, the first column is what? Is groupings, so like character, or in this case a factor, because they are into what? Groups. Okay, and then lastly, the list. List, we create it with the same list, but as I said, when you have different data structures and you want to put them together, so a client, this is for a particular client, they have other data types, then you put them in what? In a list, sort of. So that's it with this case, or the data structures. The data types, as I've explained what missing values are. Character, we've seen numeric, we've seen factor. So if you look at this, it tells you that this is what? Factor of what? 3 levels. Okay, control and so forth. So we will see later on factors with what? Ordered levels, which means I can get like grade in an exam. So A, B, C, D, E, F. Okay. Once you got A, we know that you scored more marks than what? The person who got a D, and so forth. So that's it. Okay. So yeah, that's it with what we wanted to do. So what have we done today? We've gone through our course outline. We know what is expected of us. we've gone through the R studio environment. We've also seen what data structures are and data types. When we meet next week, I'm going to send you the recordings for this and also a recording for the